All right, so it's hit 11 o'clock. We do record this, so we will be sending this out to anybody that missed it, or if you have someone in your organization that wants to see it, we can send them a recording or do a one-on-one with you guys. So today we're going to talk about stainless steel. Normally you think Belzona is, it's either stainless steel or Belzona, but there's a lot of cases where we do actually repair stainless steel, or we're actually coating stainless steel to protect it. So we're going to talk about stainless steel properties, why you would use stainless steel in a specification. Can Belzona be an alternative? And then some coating applications we have done on stainless steel. So stainless steel, just to give you a brief overview, I'm sure everybody's really familiar with it. It's used throughout the industries for its increased corrosion resistance. That's due to its chromium content, which creates that protective chromium oxide layer. Generally, you're going to use it to have that extended equipment life due to the increased corrosion resistance. You're also going to use it in some high heat resistance applications. Just like Belzona, there's a lot of different stainless steels, and you're going to choose the specific stainless steel for the specific application. So your grade 304 is typically your standard stainless steel. It's widely used in the food and beverage industry, um, petrochemical industry, marine industry. It's going to have your 18% chromium, 8% nickel. It is subject to pitting corrosions in warm chloride environments and subject to stress corrosion cracking and elevated temperatures. If you want to step up your corrosion resistance, normally people will go with a grade 316. So this is generally considered your marine grade, but we have seen some issues in seawater environments, which we'll get into. We have some applications. But 316 has the molybdenum added, and that's a tough word for me to say all the time, but it has the molybdenum added, which increases the corrosion resistance. You have your grade 321, which is stabilized with titanium, which gives it that elevated temperature resistance. Grade 409, which was interesting looking it up, is used in your automotive exhaust systems. So it's really good versus off gases, atmospheric off gases, corrosion. It actually forms a light rust that slows down the corrosion, but doesn't have that fancy appearance that you want with your stainless steel. Finally, another grade is going to be your super duplex. Grade 2507 is part of that super duplex family, which has all the additives that make it some of the more superior corrosion resistant applications. So in your really critical applications like oil and gas exploration, you might have to go with your super duplex to avoid any corrosion issues down the line. So going into corrosion of stainless steel, there's definitely a lot of high temperature corrosion cases, in the 400 to 1000 F range. Just to let you know, Belzona temperature limitations are around 350 to 400 F. So if you're having some of these issues that typically occur above 400, somewhere in the 700 to 900 F range, Belzona might not be the alternative in that scenario. This is definitely big issues within the industry, and some of the ways you fix this is upgrading your metallurgy to super duplex or something even better than your standard stainless steel applications. So something that we could help with, which is a pretty common corrosion phenomenon, is ammonium chloride corrosion. So this is when you have pitting under ammonium chloride or amine salt deposits. The ammonium chloride salts can precipitate and they form deposits on your substrate, and then you'll get pitting corrosion underneath it. So all of your stainless steels can be susceptible to this, especially your 300 series alloys. As you increase up to the alloys of the 400 and the duplex, you're going to increase the resistance to this, but you still could have some problems. Some of the common units are going to be your crude tower overheads. So anywhere where you have the HCl and the ammonia going from a hot to a cool where they can deposit, you can have these issues. So one of the ways we prevent this is, you want to limit your chlorides via desalting. There's also water washing operations to clean out your salts, or you could go with the Belzona protective coating. So going into ways to prevent it, Belzona liners, if we can handle the surface, we are resistant to ammonium chloride. So typically salts are corrosive towards metals. However, salts are not very aggressive towards non-metallic coatings such as epoxies. So you'll see we have a lot of testing versus salts. So if you do have a service where you're using stainless steel to increase your corrosion resistance, but you're still having some issues due to salt deposits and pitting corrosion, if we can handle the service as far as temperatures and other chemicals involved and pressure, we could be an option to coat that problem area and protect it from further pitting corrosion. Now, the other way we can help is if you go back to this slide, one of the ways the industry deals with ammonium chloride corrosion is to have a desalting service before you go into your crude tower. So typically refineries will have a desalter before they go into their distillation process. Now these desalters typically what we've seen is they're made of carbon steel, and most of the times they are aligned with a internal liner. So we do a lot of liners for desalters. This is just one application done last year. Had some good pictures, so put it in here. This was operating at 284, 150 psi, and had oil, gas, solid, salts, and water mixture. And as you can see, this is the full process. So we blasted the internals and applied a 2-coat spray applied liner. We also did nozzle inserts, which is a tube fabricated out of Belzona that's inserted into the nozzle and glued in with Belzona to have that coverage throughout the nozzles. And this is your finished product. So basically we have ammonium chloride corrosion, which is going to affect your stainless steels. And in this service, typically you're going with an upgraded metallurgy, but you're still having that problem. So what industries do is they, wash out their salts before it enters the process. But you need to protect that vessel that's washing out the salts, because that's obviously a very corrosive service as well. So you know that it's going to affect your stainless steel. So can you look at the other options of carbon steel coated with a coating that can handle the salt service? So that's what we do here. So 2 ways we can help that ammonium chloride corrosion is, one, coat it at the source, or coat it at the source before it goes into the ammonium chloride aspect. So another issue you can have with stainless steel is just your typical cooling water corrosion. So this can happen, just all grades of stainless steel can be affected, just because you're going to have your chlorides in your cooling water. You're going to have dissolved salts, gases, organic compounds, and even microbial activity, which can lead to MIC, microbial influenced corrosion. So increasing your cooling water outlet temperature will increase corrosion and fouling. So fouling is another issue you're still going to have with stainless. And also 300 series stainless steel can suffer from pitting corrosion, crevice corrosion, especially in that salt water, seawater, brackish water, which is a lot of what we see in the field. So going into some examples, like I said before, 3/16 is known as the marine grade, but you can still have issues, especially dealing with seawater, high velocities, increased temperatures. You're going to have corrosion, erosion. So this is one where there was crevice corrosion at the gasket. Instead of having to buy a new filter here and have the same issue over time, what they opted to go with was a flange face forming with a non-metallic Belzona 1111. So basically we prepped the flange and fabricated a former to go over the top, and we made a new flange face out of Belzona 1111, which is resistant to salts and also takes away that pathway for the salts to get in that crevice and cause crevice corrosion with stainless steel. So instead of them having to buy a whole new stainless steel asset, which we know are expensive, with a couple units of 1111, they're able to refurbish this and also make it more effective as far as corrosion protection. Another stainless steel, offshore, we see that they use a lot of seawater for cooling water, and you see that in a lot of plants, anywhere from a power plant to a petrochemical plant. If you're next to the seawater, it's a good source of cooling water. You have a source of cooling water, but then you also have a source of corrosion. So in this case, they were having some corrosion at the weld. It was undetermined. It was, since they were in service and couldn't really go down and do a detailed inspection, it could have been a little bit of internal corrosion at the weld, which could have been a combination of crevice corrosion or a weld heat affected zone corrosion. But anyhow, it was localized at the weld. It did end up leading to a pinhole defect. They were able to do a small shut-in, and we came in and performed an ASME engineered wrap. So this got them by to their next turnaround where they could do a more investigative inspection, see what was wrong with their equipment. Is this the right specification for the service? Do they need to upgrade metallurgy? Do they need an internal liner in some of the areas? So we do also offer internal liners, which can be applied on the insides of pipes, especially in spool sections that can be taken in and out. That's an easier way to coat it. So we're looking into what we can do to make this system more robust. And then going into what I think I see the most with stainless steel, which is our chloride stress corrosion cracking. So if you guys are in the industry, you know you've seen this plenty of times where you have cracking on your stainless steel due to chloride levels in your process. Increasing the chloride levels is definitely going to increase the likelihood of cracking, but there's, as per API, RP 579, there's no practical lower limits of chlorides. The chlorides can concentrate in any area they can within the process and form this stress corrosion cracking. So susceptible materials in order of increasing resistance are going to be all your 300 series stainless steels, your duplex, and even your nickel-based alloys, but these are going to be the most resistant. So any nickel-based alloys with more than 35% are shown to be very resistant to the chloride stress corrosion cracking. So any of your 300 series piping and pressure vessels are going to be susceptible. You're going to see this more in your water-cooled condensers and process side of your crew tower overhead condensers. You can even see it like in this picture on the externals with the CUI scenario where the chlorides in the insulation, when they have a CUI, can penetrate the metal and lead to catastrophic event because you can't see it because it's under the insulation. So definitely, I would say this is what I see the most and what we repair the most, and it's pretty frequent, to tell you the truth. So going into some examples, this is a 304 stainless steel pressure vessel, the head to a pressure vessel. It had several cracks right around here. We did a dye penetrant test to find them all and then installed an engineered wrap. We also terminated the cracks that we found. It was leaking in service, so they were able to take it out and do a good repair. So we did an engineered wrap on the inside and also on the exterior. As you can see, the pressure vessel, you have several nozzles, so you do need some techniques to go around the nozzles. And then we also installed a protective liner on the inside. It did have HCl on the inside, which is probably where the chlorides were coming from. So it had a small percentage of HCl, and it also had some alcohols and ketones. Pretty aggressive process, up elevated temperatures operating above 250 F. So we went with our high temperature liner and our high temperature resin with our carbon fiber to do the pressure retention. So this is typically our go-to for this scenario. If we can get to the inside, we have repaired this from the outside only, but if it is something where we can get it from the inside, then you're protecting your stainless steel from being exposed to the chlorides in the first place. Same scenario here. So this was a upset caused by which caused an unplanned shutdown. They were having some localized cracking around the vessel due to chlorides. Actually had a hole through, which caused the upset and the shutdown. So we were able to react fast and find a system that could handle the temperature, pressure, chemicals. And we used the same sort of system that you saw in the last example. In this case, we used a fiberglass instead of a carbon fiber, and we used the liner with the fiberglass. So instead of doing a carbon fiber wrap and then a liner, we embedded the fiberglass with the liner in a one-step process, which this was done because this was a lower pressure application, and it was just a little bit easier of an application than the last one, which was a little higher pressure application. So it worked great. We installed it, let it cure, got them back into service. It's been in service for about 2 years now. We do plan to put an external wrap eventually just to get it API 510 approved. And moving forward, this is a solution they're looking into for some of their assets to prevent chloride cracking in the first place. So again, kind of same scenario here. This is the tank. Had some chloride cracking right at the nozzles. So, right around the welds, which is going to be your most susceptible area. So as you can see, they did a dye penetrant, found the cracks, This was in the vapor space, and it had vinyl chloride monomer, which is going to be your source of the chlorides most likely. And we, again, went for the same system. If we can get it from the inside, we'll put any sort of reinforced repair that can hold pressure. So it's forming a wall on the inside of your vessel or your tank that's going to allow it to hold the pressure. It's also has to be chemically resistant to the system. So this was top coated with an additional top coat to add some chemical resistance. But basically what we're doing is isolating that stainless steel from the environment to prevent that chloride cracking from occurring anymore. So stainless steel, it's very similar to Belzona as far as when to use it. You look into your temperature, your chemical, your pressure, your possible contaminants, your cleaning, shutdown processes, external stressing and loading. Just like our products, they'll have a chemical resistance chart, which shows your corrosion rate. There's times when stainless steel is a great specification. There's times when it might not be the greatest time to use it, especially when you have chlorides, or if you can get away with using a carbon steel or a carbon steel coated. So economically, you have to look into that as well. So Belzona is the same way. So we'll have our corrosion resistance charts, so you can see, can we handle that chemical? Is it more economical and fit for service to use carbon steel coated with Belzona, or do I need to coat my stainless steel as well to protect that from any possible contaminants that are in the process? So we look into the temperatures, the chemicals, the pressures, possible contaminants, the same way you would spec in whatever metallurgy you need for your process. And that's the way we do it. A lot of people ask, can we stick to stainless steel? Can we stick to copper? Can we stick to brass? We basically stick to any metal as long as you prepare it correctly. So if you do have an issue with one of your alloys, we can repair that as well. And that's about all I had. Next week, we're going to be talking about cold bonding, which is an alternative to lap welded patches. So stay tuned for that. That's going to be the first Thursday of next month. And if you have any questions, feel free to unmute yourself and go for it.